Bismillahirrahmanirrahim. Nahmaduhu wa nusalli ala Muhammad Rasulullahi Kareem. This problem is related to partial differentiation of differential calculus. If z square plus 3x plus 3y is equal to 0, prove that del 2z over del x square plus del 2z over del y square equal to 2z x minus 1 upon z square plus x whole of cube. We are given that z square plus 3x plus 3y is equal to 0. I write it as a equation 1, and for finding value of this I differentiate it with respect to x partially first, then y differentiating. So I write it differentiating equation 1 partially with respect to x. When we differentiate this, we can consider there are two functions, first function z and second function this bracket. Differentiation with x, apply product rule. First function as it, differentiation of second, differentiation z square is equal to 2z, and but it is not x, so differentiation of z with respect to s with respect to x according to chain rule, plus differentiation of 3x which is equal to 3 into differentiation of x equal to 1. First function as a differentiation of second plus second function as a z square plus 3x differentiation of first means del z over del x, differentiation of 3y. For x it is a constant, so differentiation of constant is equal to 0. Differentiation of 0 with respect to x is equal to 0. Now open the bracket and multiply z to both the terms. We get to z into z square del z over del x plus 3z plus z square plus 3x del z over del x equal to 0. Now here in these two terms del z over del x common, so take out del z over del x from these. We get first 2z square 2z square. First we write in next page 2z square plus next we get this bracket z square plus 3x after taking common out from this del z over del x, and remaining term is 3z. I write here 3z is equal to 0. On adding these two terms, 2z square and 1z square equal to 3z square plus 3x multiplied by del z over del x. On transferring this term on right hand side we get minus 3z, and take out 3 from here, we get z square x del z over del x is equal to minus 3z. Cancel out 3 from this and we can find the value of del z over del s, which is equal to minus z over z square plus x. After it we will find the value of which we use in proving of given equation. So I find del 2z over del x square, which is nothing but differentiation of del z over del x with respect to x partially, but this value we have find here. So write this value and differentiate this value is minus z over z square plus x. Take out minus from this bracket and only we have to differentiate z upon z square plus x. Apply formula numerator by denominator. So we know that applying formula whole square of denominator and denominator as write as it, and differentiation of numerator minus numerator write as it, differentiation of denominator z square plus x minus z square plus x whole square. It is value of del 2 z over del x square. Z square plus x write as without any change, and this is value of del z over del x, which will I write from equation number 1. This value will be written from equation number 1. Z differentiate these two terms, we get 2z, but it is not x, so differentiate it according to chain rule, del z over del x, and differentiation of x with respect to x is equal to 1. Now we have to solve these terms because there are two terms of del z over del x, so we have to solve it. Z square plus x del z over del x. Now opening this bracket we get minus 2z square del z over del x, and minus z multiplied to 1 we get minus z upon z square plus x whole of square. Now in these two terms we will take out del z over del x. We will get in this bracket z square plus x and minus 2z square. Apply curly bracket and take out del z over del x. In these two terms write minus z as it upon z square plus x whole of square minus z square plus x whole of square, and on solving these two terms we get x is plus what 2z square is minus here, and z square one times is plus here. Difference of this is minus z square, and that is coefficient of del z over del x minus z. Now take minus to this bracket, then a sign will be changed. This sign will becomes positive, but sign of x will become negative, and this sign also positive, and we will find the value of del 2z over del x square. So I write in the next page. It will by this we will find the value of del 2z over del x square, which will be used in the denominator is z square plus x whole of square. Numerator is I multiply minus we get z square minus x. I write positive first and negative value is on second place, del z over del x. Also this minus convert to plus z. Now we can put the value of del z over del x from equation number 1, which is del z over del x equal to minus z upon z square plus x, minus z upon z square plus x. So I write from equation number 1 z square minus x, it is value of del z over del x from equation number 1, which is equal to minus z upon z square plus x plus z upon z square plus x whole up square. We use equation number 1 here, so I write here using equation number 1. Now we should solve it by multiplying this value to here z, or we can take out z from this bracket, or we can write it as multiply to this here. We get z and z square minus x numerator, and denominator is z square plus x, and plus z is here. Denominator is z square plus x whole half square. We can write z as z upon 1 because this is fraction, so I convert it also in fraction and take LCM. LCM 1 and other is other, which is equal to z square plus x. Then 1 multiply to this, we get minus z square minus x, and this value multiply to that, we get z and z square plus x. We can also take out z from this bracket, or calculate as it. This is denominator, so it go to this value of denominator and multiply to this, then 1 power and 2 power, it becomes 3 power z square plus x whole power 3, and we have to write this numerator here by taking z common out, and we get only minus z square minus x and plus z square plus x. On opening the bracket, this bracket we will get minus z square plus x plus z square plus x whole upon z square plus x whole up cube. Here z square plus and z square minus cancel out, only we get 2x z into 2x upon z square plus x whole up cube. So we find the value of del 2z over del x square, which is equal to 2zx upon z square plus x whole up cube. Now we write it as equation number 2 because we need in improving this, and also we have to find this value. So find del 2z over del y square. We must multiply this value equation 1 with respect to z. So I differentiate equation 1 with respect to z by taking first and second function as previously I do. So I write differentiating equation 1 with respect to y. We get first function as it differentiation of second, which is equal to z square plus 3x plus second function, write second function as it differentiation of first function with respect to y, and differentiate plus second term. 3 is constant, take out from here, and differentiation y with respect to y is equal to 1, equal to right hand side differentiation 0 is 0. Now we should differentiate here, write z as it without any change, and differentiate z square. We get 2z, but it is not z, it is not y, it is z. So differentiate z according to chain rule, del z over del y, plus what differentiation of 3x with respect to y is 0, because 3x is constant for y, because it is partial differentiation, and write its value as it without any change. We write next term plus z square plus 3x into del z over del y plus 3 is equal to 0. Now open this bracket and multiply z to this term. We get 2z square del z over del y plus z square plus 3x del z over del y, and take minus 3 to right hand side, we get minus 3. And also this is common to from both terms. Here is plus sign, this term first and second term, and take this common out, we get 2z square plus this value z square plus 3x del z over del y. Right side is equal to minus 3, this becomes 3z square plus 3x del z over del y is equal to minus 3. We can find the value of del z over del y by now. Minus 3 upon 3z square plus ka 3x, we can take out 3 common from denominator, z square plus, it becomes z square plus x, and cancel out 3, and we get value of del z over del y is equal to minus 1 upon z square plus x. I write it as equation number 3, or we can write it as if we consider power is because it is constant for both x and y, so I consider it is power 1. I consider it only one term, so I take it to numerator, then its degree becomes sign change minus 1, and it is value of del z over del y. It will help in finding the value of del 2 z over del y square, because it is equal to differentiation of del z over del y with respect to y again. So I write this value and get I write this value as it, and value of this is equal to minus z square plus x whole power minus 1. Since minus is a constant, so I take out from here, and only we have to differentiate z square plus x whole power minus 1, considering it is a y, and differentiation of y to the power n equal to ny to the power n minus 1. So I apply this formula here by considering it is a y, and y to the power n minus 1, but it is not y, it is z square plus x, so we have to differentiate its value partially with respect to y according to chain rule. We can also differentiate it again by considering numerator and denominator, as I do in previous section. Minus minus multiply plus, so it becomes plus, and z square plus x whole power becomes minus 2, and differentiate it with respect to y, we get 2z, and differentiation of z with respect to y del z over del y, and differentiation of x is 0 with respect to y, because for x y is constant. For partial differentiation we can write it is in denominator, so degree become positive, so z square plus x degree become positive, so we can write z square plus x whole power plus 2, and we should write put the value of del z over del y from equation 3. So I write this value which is equal to minus 1 upon z square plus x so on multiplying 2z to 1, we get in next space the value of del 2 the value of del 2 z over del y square is equal to, first factor is 1 upon z square plus x whole square. In bracket it when multiply 2z to 1 we get minus 2z upon z square plus x. On multiplying these two terms, these two factors, plus minus multiplication becomes minus, and 1 multiplied to 2z equal to 2z, and this is same bracket, here degree is 1 and here 2, and so base is equal, and on multiplication indices will add, so 2 plus 1 is becomes 3. This is value of del 2z over del y square. It I write it as equation number 4, and adding equation number 2 and 4. Now to find the result, adding equation 2 and 4, for this we add left hand side of equation number 1, equation number 2, plus add the value of left hand side of equation number 4, we get left hand side, and on adding the right hand side, equation number 2 right hand side is 2zx upon z square plus x whole up cube, and add the value of right hand side of equation number 4. In this which is value is minus 2z upon z square plus x whole up cube. On opening this bracket, this sign becomes negative, and 2zx upon z square plus x whole up cube minus 2z upon z square plus x whole up cube, and take out and we can take z square plus x whole up cube LCM, and since LCM this value is same, so we can add directly 2zx minus 2z, and 2z is common here, 2z, then here remaining x, and 2z is common, and we get only one here, and z square plus x whole up cube, it is del 2z over del x square plus del 2z over del y square, which was to be proved. Thank you very much indeed for listening me. Wa akhru dawana alhamdulillahi rabbil alamin.